Good afternoon or good morning to everyone, depending where you are. Welcome to this, I think it's the fourth webinar in the series, which is going to be, as Magda anticipated, about SPARQL, knowledge graphs querying, and conversational access to them. My name is Matteo Romanello. I'm a research and development lead project manager at Odoma, which is a small medium enterprise based in Switzerland, where we develop AI-based solutions, mostly for the cultural heritage, private or public. And I'm leading work package 4 in the GRAPHIA project, which focuses on large language models for the social sciences and humanities. So let's come to the objective of today's webinar. Will not cover, there will be some things that are not covered. So the first objective for me is for you to learn about what is the potential of using AI, and to be a bit more precise, large language models for the exploration and the querying of knowledge graphs. To get a good understanding of the challenges that relate to this process, which we will be calling text-to-SPARQL generation. So to go from a natural language question to a structured SPARQL query against a knowledge graph. And also the third objective is to let you discover the work, which is of course very work in progress, because the project it's still ongoing, that we are carrying out on this topic within GRAPHIA. And there will be also some sneak peek previews and some things that are very much in progress. Also, we would like to. It's a great opportunity to have. I think there were at least 60 people, maybe even more, which to some extent we don't know really. So we would like to make it a bit interactive. We are using for this Mentimeter with the help of my colleague Ursula, and how it works is fairly straightforward. There will be a question being asked at some point when you see a slide like this. To answer it, you either pick up your phone and scan the QR code, or go to the website and then enter this code, and then you'll be able to answer the question. And while you do that, then I'll be able to see the results. So the first one, I wanted to get a sense of how many of you have attended some, or all, or none of the previous webinars. So you can go ahead to the page, and as you can see here, we can see kind of live the voting as it comes through. We'll just wait a couple of minutes in order to give the opportunity to everyone to participate. If you have troubles with it, just I think you can write in the chat, and my colleagues will try to help you. It's already interesting for me to see that some of you have done. Yes. Let me try to do that. The code is here. And the code will be the same for all the questions. So once it's there, I think you even have to log in only once. Okay, so I think some more are coming. For me, I was saying it's interesting to see that some of you, that a good share haven't been to the previous ones. But it's also good. I'll be giving some links in the presentation to related webinars that you may want to watch, because we will not be able to cover all of them. So this was the first question I wanted to ask. I have another one, which is useful for us to, in order to be able to reach you and to make sure that we spread the news about these webinars properly. So I think we can move to the second one, which is where did you find out about the webinar and more generally about GRAPHIA? So same procedure as before. The question on Mentimeter should have changed to this one. I hope all of you have found their ways around with Mentimeter. I'm going to refresh once more. Okay. interesting as well. I wonder what the other is, but I see the good old newsletter by email seems to be quite effective. Yeah, sometimes there is a little refresh needed for the question to work. Anyway, I think I can continue, and then you can still vote, I think, and in case the results will get updated. Yeah, so before going into the topic, I wanted to start a bit from afar, giving a little bit of an introduction about what is the motivation for having this conversational access to knowledge graphs. And the first slide I have is about a knowledge graph. So I somehow assume for this presentation that you have some knowledge of what is a knowledge graph. If not, I'll try to provide kind of a brief definition, and then I have pointers in the next slide to webinars that you can watch where more knowledgeable colleagues than me cover this topic. But you can really think about a knowledge graph as of a structured way of representing knowledge that you might find in other documents, in the real world, even unstructured documents, but representing it in a structured way, in a structured and in a linked way. So an example that you have here is that knowledge contained in a form with information about an organization, about a company, which is just present in a form, can be printed, can be digital, and you have different bits and pieces of information there. A knowledge graph provides you sort of a database with structure, with interlinking between these different bits of information to represent it. And then you can also have links between other entities, other companies, for example, if that's the topic of the knowledge graph, that are present in there. I should also say that there are different types of knowledge graphs, and for this talk, we will be focusing on semantic knowledge graphs. So knowledge graphs that use RDF and derivatives or similar formats to represent the data, and that also use use OWL and RDF for the ontology, for the vocabulary of the graph, and then use SPARQL as the main interface to the knowledge graph itself. But then if you want to dig more into this topic and have also, on the one hand, more kind of precise definitions of information, and on the other hand, see how we are using knowledge graphs in GRAPHIA, I very much encourage you to check out these other two webinars, the first and the second one by my colleague, Julian, who is the technical coordinator of the project. So this is about the structure of data in a knowledge graph. But then there comes the user and comes the different types of interaction that you can have, which is very much the focus of today's webinar. How do we interact with the knowledge contained, with the information contained in the knowledge graph? And there are several types of interaction that we can find with different levels of genericity or specificity, and also of user friendliness and different technical affordances and requirements that they have. So we can start, for example, from the very generic one that many interfaces to knowledge graphs offer, which is the functionality of being able to search, either searching by keyword, or if the knowledge graph contains data related to images, also searching by image, for example. So different modes, different modalities that can be enabled by the search. Then, of course, since a knowledge graph is very much about entities being linked to one another within the same graph and with other graphs available on the web via properties, via links, there is also many interfaces provide also the ability to navigate these graphs by pointing and clicking on a node, seeing what properties, what links go out and go in into and from this node, and then navigate the graph in this way, which is a functionality that for some users might work quite well. It has some issues, for example, when it's easy to get lost in this type of navigation, and it's also not easy to navigate in this way very large knowledge graphs. Then another typical mode of interaction in interfaces is to have the properties and the values that are contained in the graph being surfaced to the user in the form of filters and faceted browsing, for example, that allow one to drill down into the content of the graph. This is typically very good when one knows roughly what they are looking for, and then they can really narrow down the field of search and get to what they are looking for, but not necessarily the best way if you don't know actually if you want to explore without necessarily a clear aim, the graph. And then there is SPARQL, which is the query language of SPARQL, which is the opposite of being generic, because SPARQL basically allows you to define your own query. So whatever the interface, the graphical interface cannot do, then if you know how to write SPARQL, then you'll be able to get to it. And that's one of the main motivations of our work in this area, to provide users ways more user-friendly and different than SPARQL to access knowledge graphs. Because we think, and we're not the only one to think it, that SPARQL has been, for many that are not familiar with this query language, a barrier to access the information that an increasing number of knowledge graphs contain. Of course, in the literature, you can find statements like this one from a recent paper, saying users find it difficult to use a formal language, query language such as SPARQL. This is a paper relating to the cultural heritage, so we might think as often, this is something that relates only to the humanities, and then we change the domain, we go to our colleagues in the life sciences, and then we find similar statements. Life scientists are often not able to write SPARQL queries. And even for proficient SPARQL users, understanding the data schema of knowledge bases can be a time-consuming and complex task. So then we find that it's not just us in the humanities, but it's more widespread than what we may think. What about the users of our project? Well, we are trying to cover and cater for a very wide range of users, going from data engineers, and here I'm referring to the work done by our colleagues and Alberta, mainly on the user personas and scenarios at the beginning of the project. And one of the personas is, for example, Eleni, who is a data engineer, who will probably be familiar to some extent with SPARQL. And then we have, at the other end of the spectrum, a professor in cultural studies like Sofia, who not only will not be familiar with SPARQL, but is also skeptical about large language models, in this case, ChatGPT. She's a bit reluctant to use them because they, according to her, they have the tendency to oversimplify things a bit too much. So these are the type of users that we are targeting and having in the project. And the same colleagues from Alberta have recently done a survey asking them about the usage of, for example, SPARQL to access knowledge graphs, and their findings. On the one hand, they confirm that natural language for 90% of the people who answer the survey, it would be a preferable way than SPARQL to access a knowledge graph. But then the other thing that I find very interesting that emerges is that at the same time, they also find the importance of transparency as a way of building trust. So the ability to see how a system generated an answer is important. And if the system is generating an answer over a knowledge graph, the way it will have done it would be to generate in a SPARQL query. So on the one hand, it's a barrier to the entry to these graphs, but on the other hand, be able to show the query that led to a certain result, it's seen as important for trust building and for transparency. And I encourage you to read, you'll find the link in the slides, the blog post that was published recently about the findings of their survey, because it's very interesting. And at this point, I think it's a good moment to ask to get a bit of sense from you of your kind of familiarity or love or not for SPARQL. So it's the moment to go over to Mentimeter for me to change the question. And you should be able to vote now for this question. And so the question is, how afraid are you of SPARQL? So it's a bit of a provocative question. And then, of course, there is if you're not at all afraid, if you're a little bit afraid, or what is SPARQL again? And I'm definitely with you in this middle part of not finding it like the most user-friendly, of like the most natural way of querying knowledge graphs. Just gonna refresh one last time. No, sorry, I jumped. Okay. Good, but it's also good to see that there is a share of you who is familiar with writing SPARQL, which is good. I'm gonna move ahead. I know I'm not leaving a lot of time for the question, but hopefully it's quite straightforward to get to it. Okay, so a little bit, I think that the middle, so it's almost like a normal distribution. The middle is dominating. And the idea is really not to avoid using SPARQL, but it's more like finding ways to avoid having to write entirely or without any assistance SPARQL. And the motivation for this is the wide spectrum with varying technical skills that we have in GRAPHIA. There is a quite steep learning curve to the language, and this also sets a technical barrier to use it. There has been over the years either approaches that want to apply SPARQL to anything, which have been to some extent successful, and then some others that try to find ways around having to write SPARQL. For example, there is this, kind of a growing number of visual SPARQL query builders that allow you basically to write a query by dragging and dropping and setting values on visual elements of a graph that should represent a query. And a good example of this is the SPAR natural interface. This is better, but still it doesn't feel as natural and fluent as being able to write your question in natural language. So for this, that's where hopefully LLMs, large language models, can come to not to the rescue, but to help, because we can leverage their translation capabilities that they have already demonstrated, for example, in text-to-SQL, text-to-cipher, in translating natural language questions into a more structured language. And this can be applied also to SPARQL, as is being already done. We're not the only ones working on this. And there is an increasing number of triple stores, so software that is able to run a semantic knowledge graph that is offering this this feature as part of their software, offering some sort of talk to your graph interaction and feature. The issue, which is also our goal, is to be able to do this independent in a way that is agnostic and independent of any backend on the underlying triple store or database system that you use for storing the knowledge graph. We don't want to be tied to any vendor in particular, but we are looking for a solution that is agnostic of the backend. Going a bit more in depth into the tasks. So when we talk about text-to-SPARQL, we're talking about a task that in the literature, in NLP, in computer science, is called knowledge graph question answering, which is quite straightforward. The system is evaluated on the task of answering a question by using a knowledge graph as the source of information to answer that question. And these are the elements that normally you find in the data that are used for this task. So you will have an endpoint that you are targeting. And then you will have a natural language question. In this case, one of the GRAPHIA knowledge graphs from ERI, so a knowledge graph gathering information from Holocaust-related archival institutions, so archival documents. And you might have the question of which archival institutions in the ERI knowledge graph are located in Argentina, what are their names? So this could be a natural language question phrased formulated against the ERI knowledge graph. And the task of the model or the agent or the system is then to come up with a SPARQL query that translates that question and then produces the results you're looking for. So when it comes to evaluating the systems, sometimes they are evaluated in how close is the query produced by the system close to the ground truth, so the one that is in the benchmark data set. And some other times we use a combination of comparing the query, but also comparing the results. So you will find different metrics and different ways of evaluating that. But this is how the task is most of the time framed, and also how the data that you can produce to benchmark or to fine-tune models on this task, how it will look like roughly. And we often talk about question-query pair, which is a pair consisting of a question and the corresponding SPARQL query. That's what you will find in the data. Let's go a bit into the challenges of enable large language models to understand what is in a knowledge graph and how to query what is in a knowledge graph. So if you want to develop a generic solution, there are some challenges that relate to how knowledge graphs appear in the wild. So when you query them without knowing what is the system behind, how they are managed, how they rate limit the usage by the user, then you run into quite a few issues. They might be related to the different backends that are used, supporting different versions of SPARQL, for example, maybe not being up to date with the latest specification of the standard. You might find different usage of subgraphs, so ways of chunking the graphs into smaller units that can be sometimes difficult to navigate. And then, of course, the other another challenge that relates to the performance is the scale of data, so the number of triples that it contains, because that changes how responsive is the endpoint, how long your query will take to be answered. And then you have some challenges that are intrinsic to the task of text-to-SPARQL translation. One of the main challenges is the alignment or misalignment or disalignment between the way we phrase a natural language question and the vocabulary that is used in SPARQL and that is used in the ontology to represent the data. So in the question I had before, you might talk about archival records, but then the vocabulary class used to represent the data might not be called in the same way, or it might be expressed in another language from the query. So you have a whole problem of aligning and realigning the vocabulary of the query, of the question, with the vocabulary of the data. And then the second main challenge is how to provide the model you're using with enough contextual information about the knowledge graph's content, which is going to be the main topic of the rest of the webinar. So let's take a look at what are the elements of a knowledge graph that a model can leverage to get this contextual understanding. So the first element is getting an overview of the content. And for this, there is a standard called void, the vocabulary of interlinked datasets, and I'll show an example in a second, that can be used to express in a machine-readable way a statistical profile of the classes and properties that are contained in the graph. So getting an overview of what is actually in the graph. Then there is the vocabulary, which is essentially the definition of classes, the definition of properties, and how classes relate to other classes via these properties. And a format that can be used to represent this, again, in a machine-readable format is the shape expressions format, for short checks, which is one of the possible formats. There is also shekel, which is slightly more complex. We decided to use checks because it was good enough for our purpose. So checks allows you to describe in a way the shape of data in a graph. It is very often, or most of the times, used for validation, but we are using it more for describing the content in order then for the model to consume this description. And then you have actually taking some samples and taking some examples from the actual data from the graph. So taking some triples from the actual graph. In some cases, this is nice to have. In some other cases, we have to do it because there are graphs that are too big to be able to generate a void and a checks in a reasonable time without overloading the server too much. And we talk in this case about taking a representative sample, which is the smallest but most representative sample of a graph, because we want to minimize the size of the sample, but at the same time maximize the number of properties that we capture. So these are the three elements that we can leverage from a knowledge graph in order to provide an understanding to the model. Here I have some examples of what they actually look like. So this is a void description of the cases knowledge graph, yet another knowledge graph from one of the GRAPHIA partners. We are also relying on someone else's software. In this case, is the void generator by the Swiss Institute of Bioinformatics. A graph provider might already have the void description in the graph, which would be very nice. But if it's not there, then we have to generate it. So this is what the void looks like. Give you information about, for example, a given class. In this case, we have a publication reference. How many times does it occur? And the same for properties. So this gives to the model a sense of what are the very frequent or the less frequent classes and properties, but not much else. With checks, there is a bit more information there about how things relate to one another. So you can see here different classes being defined, and for each class, we have a list of the properties. So having a title, an identifier, being a context for something, being an embodiment for something. And then you also have information about the type of the values of that property. So this already provides a richer representation to the model. And then the last element that I mentioned before is to get samples of the graph in order to be able to get a sense of a more concrete sense of what's inside. I will probably skip most of this slide, but I think that the main thing to take home is that to explore a graph, basically you start from a node and then you follow properties that lead you to other nodes. And this, if you imagine a graph with billions of nodes, you need to have a certain strategy or method in order to pick in the least number of attempts the highest number of properties that you want to capture. So it's basically about finding a way that is time efficient of navigating this graph in order to capture as much information as possible. And we have been experimenting with different methods and finding a good trade-offs that allow us, for example, to apply to the open citations metadata knowledge graph that contains 4 billion triples. It's one of the biggest we have in GRAPHIA. And then finding some configurations that allow us to get a small enough sample size going between 200,000 triples to 1 million, which is much smaller than 4 billion, in a reasonable amount of time. A third of a minute up to half an hour. And this will depend on the application, how long the user can wait, if this is pre-cached. So there is a lot of possible use cases there. So these three elements of context about a graph is what we are using then for our LLM agent to enable the conversational exploration of the graph. And they are, for convenience, wrapped into an API, which we call Exigen for Explore Your Graphs engine, which is an API that we have in Graphia that basically allows you to generate this void, checks, and sample for any knowledge graph. And this then we can use it basically as a way to automatically generate metadata at scale, so even for very large graphs, because we can sample them. And in this way, we can generate metadata for any semantic knowledge graph available via a SPARQL endpoint. Just taking a look at the time. I have a little bit of an interlude about benchmarking models and systems on the task of knowledge graph question answering in the SSH, because it's a very important topic. Benchmarking evaluation is a very important topic in general when it comes to NLP. But then when it comes to large language models, it's even more important. And to keep it short, it's even more important because the LLM's capabilities and landscape is evolving extremely rapidly. And basically, we need to be doing a continuous evaluation where continuously there are new models and architectures coming out that improve over the previous one. So the pace is very different from the pace we had before. So benchmark data are becoming kind of a key assets in research on these topics. And this is when it comes to LLMs, this is mostly done via benchmarks that are curated test data sets that are then used to evaluate a given model. So basically think of it as having questions that a model need to answer on a given task. Can be reasoning over mathematical problems, can be knowledge graph question answering. And then often these benchmarks are combined into leaderboards that provide you kind of an overview of which models do best based on aggregations of different benchmarks. And I think in digital humanities, there is an increasing sensibility for this topic, and some initiatives like this one they have in Basel for frameworks for benchmarking LLMs that are specific to humanities data. So these are very important and useful initiatives. However, when it comes to knowledge graph question answering, there isn't anything comprehensive that we can use for this specific task. That's why we have started Quagga, the Quagga benchmark, which is an initiative, a crowdsourcing initiative, basically to gather these question query examples from existing knowledge graphs in the SSH in order in the near future to be able to create a benchmark that can be used for evaluating large language models, similarly to what exists already in other disciplines. So for example, in computer science or in the life sciences that are already good benchmarks that can be used for this, there was nothing similar in the SSH. And I will show very briefly, because then I want to move on to the agent, what Quagga looks like, and you're all very welcome to contribute if you like. So Quagga contains two things. The first thing, it's a catalog of existing knowledge graph that can be explored by disciplines that it relates to. So for example, you can find all knowledge graphs related to literature or to history. So this will take you to the ERI knowledge graph, where we provide a brief description of the knowledge graph, the link to the SPARQL endpoint or to the dump where the data can be downloaded, an about page, downloading the metadata. This, I will not go into this, but this downloaded metadata allows you to download the checks and void that we are pre-computing for all the knowledge graphs as they come into Quagga. And then you will find pairs of natural language questions and queries. For example, can I find this is the query I had before. Which archival institutions are located in Argentina? What are their names? There is the query, there is the source. If I've taken it from somewhere else, you can run it against the knowledge graph. So this is an ongoing initiative. We have a first goal of 200 questions, and we're not doing too bad with respect to that. And you're all welcome to contribute to this collaborative effort, which leads me to ask you one more question. I think is the last question. If there is any knowledge graph that we should be aware of and that we should be adding to Quagga, so to this ongoing initiative of collecting data. I'm going to move to, so I think here you can enter text. You can try to keep it brief, can be the name of the knowledge graph, can be a link to the page where we can find the information. If it's something that is not publicly available or documented, you can also maybe leave your name so that we know how to, in case, contact you if we need more information. Feel free to enter here any knowledge graph that we should be adding to Quagga. And if you're not sure, we can talk about it in the Q&A. And with this, I would like to move to the last part, which is going a bit more into detail on how we are implementing and making happen this conversational access to knowledge graphs. There are two elements about LLMs that, even though this is not an introduction to large language models, but that you should keep in mind and to understand our approach. The first one is the hallucination. So the fact that LLMs can generate answers and text that looks and sounds legit, but it's actually factually not correct. This is due to how the LLMs are trained actually to continue a text. So they're not trained to say, I don't know, but they're trained to continue the user prompt. And this can also be related to a lack of factual knowledge to answer that question. And this is where knowledge graphs come into the play, because they can provide the knowledge that the model doesn't necessarily have to produce that accurate and factually correct answer to the question. One popular solution to this problem of hallucinations is what is being called RAG, so retrieval augmented generation. Again, no time to go into detail, but just to give you an intuition of how it works. Basically, instead of having the LLM answering directly the question by the user, we inject into the context of the prompt some information that comes from an external database. Can be a database, can be a knowledge graph. We often talk about this database in a RAG context or in terms of a vector database. Because based on the prompt, we try to get from this database snippets of text, basically, that relate to the question by the user. We injected them into the context, so we enrich the initial question with more context, and then the LLM will answer the original question based on this enriched part, which is represented here in blue. And when you're using AI-based applications, often you will know that behind there is a RAG system, because you will see this kind of footnote that the LLM or the chatbot is using to back up essentially their statements. And these footnotes indicate that behind it's using a RAG system. So these footnotes will relate to bits of context fetched from a database that help the model to reply to your question. So this is a first thing to know. And the second thing to know, it's roughly speaking the difference between an LLM and an agent. So an agent is a system that uses one or more large language models, but then it combines them also with other things. It combines them with the memory. It combines them with tools and APIs that can be called for doing searches, executing code, looking and searching into databases. And then also a control loop that basically allows an LLM to take a task from the user, plan the steps and the actions needed to satisfy that request, carry them out, observe the results, and then, if needed, reiterate on this. So the main difference is that a standard LLM will be kind of a one shot. So there is a one prompt, one response. Whereas in an LLM agent, you have an iterative process based on these loops, where the same question is not answered at the first shot, but there is an iterative process in order to get to the answer. So that is kind of the main difference. And here you have also some literature references of interesting LLM agent work done in DH. Coming to the Quagga agent, so the counterpart to the Quagga benchmark that we try to establish to evaluate these systems, we're also working on the agent side, and this is what the kind of the architecture looks like. And I will unpack it a bit. So the void and the checks and the sample, it's what comes from Exigent, so what we talked already before. The question is the natural language question from the user. So think about the question we had before. And then we have the LLM agent that is trying to reply, to answer the question by formulating a SPARQL query that provides it with the information needed to answer the question. And it does this by using two different bits of information and of tooling. So they use some tools, and it uses the information, the metadata about the knowledge graph from the vector database. So in terms of tool, you will find, for example, the scope checker that the agent is using to make sure that it's using the right knowledge graph to answer the right question by the user, because the focus of the user might change. They might query multiple knowledge graphs in the same conversation, so the agent needs to know about which knowledge graph we're talking about. There is, of course, a query validator where before running a query, the agent tries to validate it and tries to debug it if the query doesn't compile, for example. We have a tool called Query Reformulator, which is useful to overcome this problem of alignment between the vocabulary of the question and the vocabulary of the graph. And then we have this checks retriever that is used for retrieving the appropriate bits of checks that are relevant to answer the question by the user. So this is roughly the architecture we have. And as you are seeing here, we are using a smallish model for the agent and a bigger model for kind of a reasoning part of the tool calling. This said, I will very briefly, because I don't want to kind of take too much time from the Q&A, but just wanted to show you how kind of the pre-alpha version we have looks like, which is nothing very fancy, uses the Open Web UI interface, but then it's connected directly to Quagga. So the knowledge graphs that we are starting to catalog here, we are starting to make them available and queryable via the agent. No, I didn't want to ask why Quagga. That's another story, but I can ask the question of what are the knowledge graphs that I can explore. So it will check its database, see which knowledge graph have been enabled, and these are the three ones that I can use for now with the agent. So here I can say, for example, I want to use the edit knowledge graph. And as you see, it also has some follow-up questions that quite often are useful, that you can also click on to go on and explain, and explore the graph. So I can ask what information does this knowledge graph contain? An interesting thing here is that this is the checks bit coming from the RAG that is being retrieved as being relevant to the question of the user. So we are also showing a bit what is kind of the reasoning or the the elements from the context that are used by the model. So it tells me, for example, there are countries, institutions, corporate bodies, persons, record sets, and so on. Not the time to explore everything, but I can ask how many descriptions of archival records does it contain? And then I will stop there. And here I get my answer. It contains 300,000, about 360,000 elements, and this will be the query that I need to that has been run in order to get this answer. So on the one hand, facilitating the creation of SPARQL queries, but on the other hand, not hiding away the SPARQL, because it's what essentially can be used to build trust from the user in this system. And with this, I'm going to wrap up. I'm slightly over time, but I just wanted to highlight some of the shortcomings that the agent has right now, and we're working on them. So the first one is that we're using a relatively small model, 30 billion parameters with, I think, 3 billion or 8 billion, I don't remember, activated, which has limited expressivity. It has no reasoning. It has also limited knowledge, for example, about SPARQL. This is a first issue. The second issue is that right now, the agent is very sensible to the misalignment of vocabulary. So if you ask the same question in two slightly different ways, the first one is a bit not really correct, but the user might do that. If you ask how many archival descriptions does the knowledge graph contain, then you will not get the right answer. This means that it's very sensitive to the type of vocabulary that is used by the user. And then the last, but also very important shortcoming is that right now we are using basically an approach where it's essentially a zero-shot query generation. So the agent tries to get right the query at the first try. But this, even for humans, if they don't know what's inside a knowledge graph, it's very hard. That's not how a human goes about writing SPARQL. What humans do, or tend to do, is to do more of an exploration. They do first a bit of exploration of the graph with simple queries, and then they build on top of them to get to the complexity of more complex queries. So it's a more kind of explore and then query kind of approach. So that's what we are actually implementing now to replicate a more human-like way of exploring the graph. This was it. Looking forward to the questions, and here you also have our context, both personal but also for the project, if you want to reach out to us.
Thank you, Matteo. I will now stop the recording.